Start recording. Okay, this question here is about a piece of wood that is partially submerged in water, and on the upper end there's a string that is vertical. Okay, so part 1, draw a labeled diagram showing the forces acting on the rod when it's in equilibrium. So there are only 3 forces. One of them is obviously the weight. The weight is pointing down at halfway, so that is 60 Newton. Then there's a tension of the string pulling it up. Okay, tension of the string pulling it up. And obviously the third one is the upthrust for this portion that is underwater. So exactly at half of the half, that's half of the length is underwater. So half of the half here is upthrust acting, pointing upward. Okay, so these are the 3 forces acting on the rod here. Now, if you take uh, if you if you measure horizontally the length from here to here, if I call this L, now the weight will be a halfway from there, right? Because the weight is exactly the CG, right? So it should be, if the from one end to the other end horizontally is L, so in the horizontal direction from the string to the weight, the center of weight will be, center of mass will be L over 2. And since the upthrust is half of the half length or 1/4, you add another quarter length. So from here to there, the distance is 3/4 L. Okay, we're going to use all these distances for next part of the calculation. Next part, to find the density of water. So given the density of water, you find the density of wood on which the rod is made of. So I would be taking the moment about the pivot. The pivot is the good point will be at the top here. I take this point as a pivot. Then what I need to do now is to take the moment, a clockwise moment equals anti-clockwise moment. For the clockwise moment, I write U times 3/4 L, and that equals to the anti-clockwise moment, which is 60 times L over 2. So I do some cancellation here, and then I work out the value of U. I should get 40 Newton. Okay, so this 40 Newton represents the upthrust of the half the length of the wood. So I can write U as the density of water times the volume underwater. I call this underwater UW times G equal to 40 Newton. So you're given the density of water is 1000. So from here you can easily calculate the volume that is underwater. So that the volume underwater is half the length of the total volume. The total volume of wood is total volume of wood of the wooden rod is actually 2 times of this, right? 2 times of this. This is just a number. This, if you work it out properly, you should get 0.004077, and the volume of wood is double of this amount. Okay, so now we know that the weight of the wood is actually to find the density is just the mass over the volume, right? Volume of the wood, which is 2 times of this, and the mass is just the weight divided by G, right? Okay, M equals to W over G, and then divide by this 2 times the volume underwater. So you put in, this is the density of wood. The density of wood is density of wood, therefore is can be calculated from all these values here, and you work it out, you should get 750 kilogram per meter cube. Okay, right. Once we have the values that we know, the upthrust value that we know of, 40 Newton here, and this value, then the tension can be easily calculated, right? Because the last part is actually quite straightforward. The upward force plus the upthrust equals to the weight, and this is 40, and that is 60 Newton, so T become 20 Newton. Okay, so that's all for this question here.